Hello and welcome everyone. I am Tumi Chikel.
And I am Jack Marcus. We are going to present on spectroscopy assignment problem 8. This is the overall outline of the presentation. Introduction. Infrared spectroscopy or IR spectroscopy, which is also known as vibrational spectroscopy, is the measurement of the interaction of infrared radiation with matter by absorption, emission, or reflection. It is used to study and identify chemical substances or functional groups in solid, liquid, or gaseous form. Proton nuclear magnetic resonance or proton NMR, which is also known as hydrogen 1 NMR, is the application of nuclear magnetic resonance in NMR spectroscopy with respect to hydrogen 1 nuclei within the molecules of a substance in order to identify the structure of its molecules. Mass spectra are graphical representations of ions detected in a mass spectrometer, plotted as intensity versus mass to charge ratio. The primary purpose of a mass spectra is to identify unknown substances, confirm molecular formulas, and study chemical structures in analytical chemistry. Ultraviolet or UV spectra refers to the absorption spectroscopy or reflectance spectroscopy in part of the ultraviolet and the full adjacent visible region of the electromagnetic spectrum. The spectra provides insights into the presence of conjugate systems, functional groups, and electronic transitions within a molecule. Data analysis of problem 8. Compound X was found with the following elements: carbon with 73.5%, hydrogen with 12.4%. Its infrared spectrum is given in figure 1.1. Suggest a structure for compound X. Percentage check. Assuming the compound X has a total of 100%. Total percentage of known molecule is calculated by adding 73.5% of carbon plus 12.4% of hydrogen, which gives 85.9%. Percentage of unknown element is calculated by subtracting 100% minus 85.9%, which gives 14.1%. Therefore, 14.1% of unknown element in compound X. Infrared spectrum interpretation. As you can see on the infrared spectrum of compound X, the first peak, which is approximately at 2865 to 2975 reciprocal centimeter, and it shows a sp3ch strands. The second peak, which is approximately at 1715 reciprocal centimeter, and it shows a C double bond O strands. And the next peak, which is approximately at 1465 reciprocal centimeter, which shows a CH band. The next one, which is at approximately at 1390, and it shows a CH3 band. And the final peak, which is approximately at 1000 to 1200 reciprocal centimeter, and it shows a C double bond O band. These peaks are summarized in the table in the next slide. This is the summarized table, which is divided into wave number in reciprocal centimeter, observation of the peak, and the functional group. Wave number approximately at 2865 to 2975 reciprocal centimeter shows multiple and sub-peak and functional group of alkyl, which is a sp3ch threads. Wave number approximately at 1715 shows strong and sub-peak and a functional group of carbonyl, which is a C double bond O stretch. Wave number approximately at 1465 reciprocal centimeter shows medium and sub-peak, which is a CH band, and it is a methane functional group. Wave number approximately 1390 shows a medium sub-peak, and which is a CH3 band and a functional group of methyl. And the final one, wave number approximately at 1000 to 1200 shows multiple sub-peak and a functional group of ketone band. Empirical formula calculation. From the IR spectrum interpretation, the unknown element in compound X is oxygen. Therefore, 14.1% of oxygen is in compound X. Now, the empirical formula of compound X is, assuming 100 grams of compound X, carbon with 73.5 grams, hydrogen with 12.4 grams, and oxygen with 14.1 grams. Now converting grams to mole. Converting grams to mole, dividing the grams by the molar mass of each molecule. Therefore, carbon 73.5 grams divided by 12.01 grams per mole, which gives 6.12 mole. Hydrogen with 12.4 grams divided by 1.008 gram per mole, which gives 12.30 mole. And the last one is oxygen with 14.1 gram divided by 16.00 gram per mole, which gives 0.88 mole. Now convert to the simplest ratio. When converting to the simplest ratio, we divide by the smaller mole value, and the smaller mole value, which is 0.88 from oxygen. Therefore, 6.12 mole divided by 0.88 mole, which gives 6.95, which is approximately equal to 7. When we round off, it will, because 9 is round up, so it will be 7. For hydrogen, 12.30 mole divided by 0.88 mole, which gives 13.98, which is 9 is round up, so 13 will be 14. So therefore there will be 14 hydrogen in compound X. Oxygen 0.88 mole divided by 0.88 mole gives 1. Hence, the empirical formula is C7H14O. Index of hydrogen deficiency calculation. Given the empirical formula C7H14O, hydrogen deficiency or degree of unsaturation is equal to, since oxygen is in group 6, degree of unsaturation, which is initials as DOU, is equals to 2C plus 2 minus H all divided by 2. The C represents the number of carbon and H represents the number of hydrogen in the empirical formula. Therefore, when we substitute C and H, when we substitute C and H into the formula, we get 1 as the degree of unsaturation, and therefore The degree of hydrogen deficiency is 1. This indicates that compound X has one double bond or one ring.
HNMR spectrum interpretation. It has two different environments labeled as A and B. A is a doublet and B is a septet. A around 1 to 1.3 parts per million. Its proton type identified is CH3 methyl, and its multiplicity is doublet because it has one neighbor. According to n+1 rule, its multiplicity is doublet and its integration is 12H. Label B is a septet and approximately 2.5 to 3 parts per million. Proton type identified here is methane CH, and it's a septet. Why? Because it has 6 neighbors. According to n+1 rule, it is a septet and its integration is 2H. Mass spectrum interpretation. By looking at the mass spectrum, molecular weight of compound X is 114 grams per mole. This is shown by the molecular ion M+ peak at mass on charge ratio of 114. Molecular formula calculation of compound X. Given analysis, empirical formula mass grams per mole of the empirical formula C7H14O was calculated as follows. Carbon 12 times 7 is equals 84 grams per mole. Hydrogen 1 times 14 is equals 14 grams per mole. Oxygen 16 times 1 is equals 16 grams per mole. Thus, empirical formula mass is equals to 84 plus 14 plus 16 gives 114 grams per mole. Molecular weight of compound X, as we have discussed earlier, is 114 grams per mole, which was given earlier in the mass spectrum interpretation. Therefore, molecular formula of compound X is: first, we calculate the multiple, which is calculated as molar weight divided by empirical formula weight, which is 114 grams per mole. When dividing by 114 grams per mole of molecular weight gives 1. Hence, the molecular formula of compound X is 1 times the empirical formula, which is C7H14O, gives C7H14O. Therefore, molecular formula of compound X is the same as the empirical formula C7H14O. Structure of compound X, C7H14O. This structure is drawn according to the interpretation of HNMR spectrum. As we have discussed, HNMR spectrum has two chemical environments. A is doublet and B is septet, and that's labeled here in this diagram, A and B. IUPAC name of compound X is 2,4-dimethyl-3-pentanone, and this name suits the diagram above as well as the HNMR spectrum. Mass spectrum interpretation of compound X, which is 2,4-dimethyl-3-pentanone, and its molecular weight is 114 grams per mole. First fragment occurs at C3H7+, and its possible structure is propyl cation, and its mass on charge ratio is 43 and is also known as the base peak, which has a relative abundance of 100%. Second fragment occurs at C4H7O+, and its possible structure is butanol cation, and its mass on charge ratio is 71. And third fragment occurs at a mass on charge ratio of 114, and it is also known as the molecular ion peak or parent peak. UV spectrum interpretation. Sample details. Solvent 95% ethanol, concentration 99.6 milligrams in 100 milliliter, and its x-axis wavelength 200 to 400 nanometer, y-axis is measured in abundance. This UV spectrum confirms that compound X contains C2O double bond. This is shown by the wavelength range from 275 to 300 nanometer, and its transition state is transition of electron from non-bonding orbital to a anti-bonding pi orbital. This peak indicates a carbonyl group. Summary. Thus, the IR spectrum, HNMR spectrum, mass spectrum, and UV spectrum of compound X shows that compound X is 2,4-dimethyl-3-pentanol. Its molecular formula is C7H14O. Proposed structure of compound X, which is 2,4-dimethyl-3-pentanol, is drawn as shown here. Therefore, compound X 2,4-dimethyl-3-pentanol is a cation. References. These are our references. Acknowledgement. That is all. Thank you for your time and attention.